Hello YouTube. I know I promised you that we would build a base on the moon, but I was thinking that we should probably build a space station first. So today we're gonna be launching a space station, and then the next videos will be about building a moon base and sending people there and just starting all kinds of research there. Okay, SAS on, throttle up, and let's launch. Yeah, I'm gonna turn the sound on so that you can listen to the rockets firing. Okay, yeah, I'm gonna be recording all of this in one big video instead of splitting it up this time. We'll see, maybe that'll work a little bit better. Leave your comments about, well, tell me what you think about this. Also, as far as how the rocket is constructed and how the space station is constructed, I'm gonna leave that till the end of the video, and we're gonna start with the actual mission first. So, yeah, there is a bit of lag while it gets off the ground, but at worst case scenario we get the lag should fix itself once we get rid of the first stage. Yeah, and it's getting better, I think. Yeah, I probably need to get a better computer. Well, I know I need to get a better computer, but you know, actually getting the cash for it is a separate issue, isn't it? Okay, and we're on our way. Our 3 Kerbonauts are terrified, of course. Yeah. Okay. See, I'm kind of wondering if maybe I should build a base on Minmus instead, because it has a lower gravity, and if we're gonna be building things there, we're gonna use it. If the idea is to have a place where you can assemble things for sending them out deeper into space, then the Minmus is probably a better bet, but at the same time it's just a big ball of ice, and it probably doesn't have any useful material. So if we're gonna mine stuff and build stuff on the spot from scratch, at least some of it, then, well, obviously Minmus is a bad place for that, isn't it? So I haven't really decided on that. I'll probably go with the moon, but kind of thinking about it. Okay, we are... Okay, let's pause it for a second, let the processor catch up, maybe that will help a bit. Not really. Yeah, it always lags far more when I record. I try to keep the number of parts down to a minimum in order to limit the lag, but as you can see, that only goes so far. Anyway, we have half a fuel tank left, so in another 20 or 30 seconds, well, less than that, we're gonna be fine. And then once we get rid of this stage, we're gonna start our turn. Okay, pause it for a second. Okay, that's done. Goodbye. Come on. Yeah, I think we need to wait for that debris to get far enough away from us. Okay, here we go. Yeah. Here we go. So that has to be 2 or 3 kilometers away, I guess. Yeah, we're gonna be putting this station into a pretty high orbit, about 1 million meters, in order to limit the time it's in the Kerbin's shadow, so that these solar panels here are getting as much light as possible. And we're also going to be creating artificial gravity for this thing by putting it into a spin, which means that the centrifugal force will be pushing things outwards, and well, essentially you're able to get a weak gravity that way by making things spin around its center of mass, which is a fun fact and probably the easiest way technologically to, well, the only way right now to create artificial gravity. Okay, and here we have two fuel line parts which are essentially, well, sort of plastic conduits for Kerbal to crawl through to access the center part of the station. And this part here, on top of which we have attached the return capsule, is the docking assembly, whatever you want to call it. So, and there in the center we have computers and SAS, as well as two fuel tanks and a weak engine to adjust the station's orbit if for whatever reason we need it, as well as RCS. So if the idea is that when you want to dock with this thing, it slows down using the SAS, stops its spin, stabilizes itself, then the ship docks at the stop part, and then the station spins itself up afterwards after it's been refueled, re-RCS'd, re-whatever, and restores its artificial gravity. And we're going for a height of, whoops, almost missed it, right about there. Yeah, we're gonna go for 12 million, sorry, not 12 million, 1.2 million meters. And we're gonna get most of the way up there with this set of engines. Then we're gonna detach it and climb into a slightly higher orbit using this engine, so that we avoid the risk of colliding with this stage. And right now we're gonna speed ourselves up, and we're already in a stable orbit, which is good. Okay, we're gonna need to use the RCS to turn our ship here, because this stage is, even with RCS, it doesn't really want to turn. Oh, don't glitch out on me. Okay. Yeah, it's the time warp. It really hates that. Okay. And it's turning, but very slowly, as you can see. So RCS. Yeah. As you can see, we have the RCS here on top of the solar panels. And another smaller set. Whoa, it's really laggy. Okay, that's better. Another smaller set down there to stabilize it with. Stabilize this thing with. And that's just a set of 4. It's meant to compensate for any imbalance in these. These are pretty close to the center of mass, and whoa. Yeah, screw that. We're gonna push our orbit a long way upwards, although it doesn't actually require a lot of delta V, which is the difference in speed, for those of you who don't know what that means. Essentially, if you go from a speed of 1,100 meters per second to 1,300 meters per second, that's a difference of, if your just accelerating in straight line, not modifying your trajectory. That's a 200 meter per second difference of speed, or 200 meters of delta V. Well, 200 meters per second of delta V, and we need about 300 extra meters here to about 1400. Okay, and we still have plenty of fuel here, but I thought it best to have a little reserve here, so we touch this now. Okay, engines are okay. Let's turn the RCS and push ourselves slightly away from that. RCS off. Okay, and we want to make sure we are, and our engine isn't on, is it? Okay, let's turn it off. Ignite it gently. My, this is really laggy. Yes, sorry about that. Okay. 1.22 million meters. Should be. Whoops, missed it. Well, we'll get it on the next orbit. God damn it! This time warp is gonna kill me. Okay. Now, the good thing about this is that this final stage, well, the space station itself is pretty easy to turn, even without RCS, so you won't have too much trouble with it. Okay, so we are a couple of kilometers higher than this, the apoapsis of this piece, and we're gonna push our periapsis out as well, so that there is no chance of hitting that thing. Although, of course, our space station does have maneuvering capability, so it can adjust itself as necessary. Okay, that should be enough. Now what we're gonna do is we're gonna turn ourselves northwards so that these solar panels are getting sun at a nearly 90-degree angle, because that maximizes how much energy they can actually absorb from the sun. And we're gonna put a spin on this so that all the solar panels are getting a sufficient amount of sun, and we're gonna turn the SAS off that way. Since we're orbiting equatorially and we're pointing towards the top of the planet, namely at a 90 degrees to the direction of our orbit, we're gonna always be pointing in this direction. So, okay, let me show you. As I speed up time, our ship rotates around this point, but it keeps pointing northwards. So, no matter what we do, this, yeah, and it lags out when you speed down quickly. Always at the 2x speed too. Okay. Okay, that's off, and RCS on, and artificial gravity, that should be fine. And here the panels are all getting a nice amount of sunlight. Okay, RCS off, SAS on, and of course we left the main flight computer there. Okay, so now this is the last tricky bit, because we have to move away from our space station without damaging it with our engine. But since it's turned northwards, it's easy. We just turn in a 90-degree direction away from our space station, and okay, we're gonna throttle up our engines, fire them, and then immediately shut them off after we've nudged ourselves out of the way. Okay, you ready? Okay. And there it goes. Goodbye, space station. We'll visit you sometime. Well, not really, cause I have the preset on 0 to limit lag, because that of course takes up resource simulating the breeze, so it's gonna be deleted after we finish this flight, but it's the thought that counts, right? Okay, and now we're far enough away that we can throttle up and head down into a lower orbit. And we're gonna want a nice shallow landing close to the space center, so we're gonna bring our periapsis down to 300,000, and then we're gonna bring our apoapsis in, and after that we set up our landing approach. And there it goes. Okay, at periapsis. And here of course we have a really small final stage because, well, we are just returning from orbit with this and we really don't need a lot of fuel. Also, the lighter it is, the less fuel and less engine you need to move it. So again, we really don't need any more here. It's like a bare minimum to make a controlled rocket that will stay pointed in the direction you want it to go. Just an decoupler, well, command part parachute, decoupler, SAS, small fuel tank and small engine. Absolute bare minimum. In line with our current policy of more boosters isn't always better. Now what we want to do is set up a targeted landing. Where we at? Oh, and half an hour. The planet can't rotate far in that time, and we are gonna have more than enough fuel to actually adjust as we get closer anyway. So where we at? Right about there. That will do fine. Let's, yeah, it doesn't have a computer control on it, so it handles a bit differently. It's just a SAS unit. And the space station has two computer units, a flight computer for modifying orbits and a scientific computer for helping with various experiments that are going to be carried out there. So, let's head down. Okay. And of course you want a orbit, a periapsis of about 32,000 meters above the point where you want to land, taking into account the rotation of the planet. So, by the time we reach that point, the atmosphere will have slowed us down enough that we can actually land at more or less that point. So, that's how you can do a targeted landing. And in adjusting for the orbit of the planet, you can use this time to help with that. Although I should probably look up how long it actually takes for Kerbal to complete one full rotation, but just Google it and then use this time to figure out how far Kerbal actually rotates in that time, and then you can do a nice targeted landing. You can come down somewhere here, I'm pretty sure of it, but we'll see. And of course it also helps if you do it from a low orbit, because then you come in more shallowly, and when they add re-entry heat and things like that, it's really gonna help. Coming in like this from a low orbit at a shallow angle to avoid burning up in the atmosphere. and our periapsis is going down because the atmosphere is slowing us down, and we are not in the really thick atmosphere yet anyway. So yeah, it's gonna slow us down. When you set your periapsis at 35 to 32,000 meters, it ensures that you go below the 32,000 meter line at some point, which means you reach this thick part of the atmosphere, which is what does the main part of dealing with your speed, with getting rid of your speed. So yeah, we're gonna land somewhere here, like we expected. Yeah, you can see we no longer have a periapsis, we're no longer in orbit, and we're heading in. And now we really start to slow down. As you can see, speed is going way, way, way down. We could burn some fuel if we wanted to, but we're not gonna. So we get rid of that, and we can wait until we... But no, let's open our parachute as quickly as we can. The higher up in the atmosphere you are, the less force the parachute exerts on your capsule, which also has the benefit of not just avoiding any chance of snapping off your parachute, but sorry about that, just got mail, but also limits the G-force you guys experience. So you have to, if you want to avoid killing your guys, you need to open your parachute either until you're really way down, or when you hit the 20,000 meter mark, which is the soonest that you can open the parachute. You know, you need to open it either really late or really early. Okay, so this is a successful mission, and I think they never once calmed down until now. And now, I mean, look at those eyes, it's like they're dead inside, paralyzed by the horror. Okay, and flight. Vehicle assembly building. And now I'm gonna show you how this thing is constructed. Okay. Okay, let's start with the space station. We have the RCS thrusters here, which do the main work of turning and spinning the ship, as well as 4 RCS thrusters here to stabilize the spin and keep the turn stable, because if you have a single set of RCS thrusters and they're off center, they're not gonna turn your ship accurately, there's gonna be drift. So if you're just gonna use RCS thrusters for turning your ship, you either want one set at the very end of your ship, probably next to the command capsule, because you'll be getting rid of the earlier stages, or you want one big set towards somewhere near the center of mass and a smaller set to stabilize things. So, okay, there's the RCS thrusters for turning and spin control. Plenty of RCS fuel, since spinning the ship up requires relatively little. Spinning the station up. We have the solar panels which provide the station with power. We have the main habitation/lab modules attached to the center here with these hardpoints which transfer electrical power and air and everything else. We have the computer cores here, of course, and actually let's undo that last move. Give it a second. Okay, here we go. These fuel lines are what these plastic tubes are what the astronauts use to move from the outer parts, well, from the outer modules to the inner ones, and I'm assuming since they're so close that they're just connected rather than separate. Okay, get rid of that, get rid of that. Here we have the main flight computer, and here we have the scientific computer. And this is the docking assembly here. And here we have the orbital adjustment engine along with the stabilizing RCS. Okay. We can get rid of the center of the station here, and now we gonna examine the launch vehicle. We have two main stages, the center one with vectoring engines, the outer one with the raw power engines, with the center ones feeding into the inner ones, which means that these 4 fuel tanks last about as long as 2 fuel tanks would last in a normal situation, which is enough to get us out way up there, out of the first 2 stages of the atmosphere, up to 35,000 meters. And of course they're strutted together and decoupleable. Now there's 8 engines, and yeah, it's hard to set up, but if you're careful you can get 8 here. And there's 2 central fuel tanks here, which just serve as a centerpiece to attach this like that. And this is a new design which I'm liking, where you just add a central stage like this, center point for, so that you add a center point like this so that you can detach it all as one unit, and then you add a cluster of 8 engines like this, making for a powerful stage like this. So and then you add a second set of engines there if you want some real power, and you have a nice workhorse of a rocket which does a pretty good job lifting you into orbit and beyond. And here we have our bare minimum return capsule along with our standard command pod. And that's how you launch a space station. Like, favorite, subscribe, leave comments, ask any questions you might have, and goodbye YouTube.